Welcome to Section R.4, working with rational expressions. All right, so a very important thing is the domain of an algebraic expression. The domain is a set of all real numbers for which the function is defined. So pretty much, if we're thinking of a rational expression, again, rational, the word ratio is in there, if you can see that. So we're talking about fractions. And when are fractions considered undefined? They are undefined when the denominator is 0. Okay, in a fraction, we're not allowed to have the denominator equal 0, so that would be when our fraction is undefined. So when we're trying to find the domain of the expression, we want to find the number that causes the problem and take it out. Or another way of looking at it is we want to find all of the numbers that make our fraction okay and do not give us a 0 in the denominator. Again, that is the goal. Look for the number that creates a 0 in the denominator and take it out of your answers. So for this first one, this first fraction, how do we determine what number makes us 0? Well, we're going to go ahead and look at x plus 7. We know that this cannot equal 0. So let's go ahead and solve for that number. Solve it like an equation, and we get x cannot equal -7. So if we're looking at a number line, where this is 0, the number -7 is the only one that we can't allow to be in our solution set. To write this in set builder notation, we'll go ahead, do our little set notation. So our x can be the element of the real numbers. Again, this weird looking e means element of. R means the real numbers. It can be all of the elements of the real numbers except what? Except we know that x, such that x cannot equal -7. And we're done. That's the answer for set builder notation. All right, let's take a look at the next one. Again, feel free to pause the video and try it out yourself. So for this one, there's a new thing going on. We have a variable in the top, but we're not going to really worry about that at this time. It's not going to be interacting with our denominator, because even if we simplify this, we can't simplify something for the top and the bottom. So again, what's our goal? Figure out what makes the denominator 0. So to do that, we'll set our denominator to 0 and figure out what number makes it 0. Again, let's go ahead and solve our equation. We know 3x can't equal 10. Let's see, divide by 3 to get x by itself. And we find out x cannot equal 10 divided by 3. Okay, so again, in set builder notation, x can be all elements of the real number, but we know that x cannot equal 10 divided by 3. And we are done. All right, let's take a look at the next one. Find the domain and simplify the expression. All right, so again, to find the domain, we're going to want to first focus on the denominator. So I'm going to go ahead, since we're doing two different things, I'm going to label them. This is for my domain. Again, we don't want the denominator to equal 0. So let's go ahead and figure out what number makes it equal to 0. And I'll set my denominator equal to 0 and say it can't equal that. So let's see. Ooh, I have a quadratic equation. So I'm probably going to try factor this. But first, let's try simplify. I'm going to divide everything by 9. If you can make the numbers smaller, might as well do that. Less work for you. That cancels. This simplifies with a 2, and that simplifies with a 3. So now we have m squared plus 2m minus 3 cannot equal 0. Can we factor this? We can, so that'll be m plus 3 times m minus 1 cannot equal 0. And then we have two different things. So m plus 3 cannot equal 0, and m minus 1 cannot equal 0. Solving these, we get m cannot equal -3 and m cannot equal 1. Again, this should be the amount of work you should show for your quizzes or for the final exam. So again, when I'm doing these lecture notes, the way I show the work is the way I would expect your work to be shown when I'm grading any handwritten work. Again, if you have any questions on that, send me a picture and email me, and we can chat back and forth about that. Alrighty, so Again, this is the domain. So what numbers do we have to take out? Well, x is going to be elements of, oh, we're not talking about x anymore, we're talking about m. So let me go ahead and erase that. We've got to be careful. We have to use the variable that we are using. And that's going to be m. So m, element of the real numbers, and then we have a restriction. M cannot equal -3, and m cannot equal -1. Other than that, all the other numbers are fine. All right, and then let's go ahead and see if we can simplify our expression. Can we simplify this? I'll write out what I'm doing. Simplify. Well, let's see. I'm going to factor from the top and the bottom. So let's see. I can factor out a 3 in the top, so it's m squared minus 9. Divided by, in the bottom, again, we knew we can divide out 9. That'll be m squared plus 2m minus 3. Ooh, and we can simplify from the top and the bottom. That 3 cancels out. We're just left with a 3 down there. And then in the numerator, we have the difference of 2 squares. Ooh, and we know we can also simplify this. Let's go ahead and do that. We have m squared simplifies into m minus 3 times m plus 3. And then in the bottom we have 3, and we have m plus 3 times m minus 1. Okay, so let's see. Ooh. And then the m minus 3's would cancel. And I would be left with m minus 3 times 3 over m minus 1. And that would be a simplified version of my rational expression. Okay, again, so when you're doing a few different things, it's good to label out your work to let your reader, which would be me if I'm grading, let me know what you're doing. All right, so let's take a look at some other things, multiplying and dividing. Example 3, perform the indicated operation. Okay, so for part A, what is the indicated operation? It's multiplication. So what is my plan? Well, first I'm going to simplify or factor out each of the terms. So simplify, 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 and then see if anything can cancel before I try to multiply. Again, if you can simplify first, that keeps things from getting too large. So let's see, in the top, I can factor out a 5. So that'll be n plus 5 over, now in this bottom denominator, I can factor out an n, so that's n times n minus 1. Okay, bring down that multiplication sign. The top can't factor, so it's just 10n. Now the bottom trinomial, I think I can factor that. Let's see, n plus 5 times n plus 1. Now again, if you need any reminders or any help on factoring trinomials, please just send me an email and I'll send you some worksheets to practice on. Again, assuming that coming into this course, you have already seen this and you know how to factor. But again, if you don't need some review, just let me know and I'll send you some reviews. Okay, so now everything's factored. Can we cancel any terms? Well, this n can cancel with that n, and then the n plus 5 can cancel with the other n plus 5. Okay, that's all that can cancel, so let's go ahead and see what we have left. We have 5 over n minus 1 times 10 over n plus 1. All right, that's all we have, so we'll go ahead and multiply that out. 50 divided by n minus 1 times n plus 1. I would not suggest multiplying these out. Leave it in the factored form. That way I know that you know how to keep it factored. All right, and that's my final answer. For the next one, B. What are we being asked to do? Ooh, division. Okay, but my plan's not going to change quite yet. I'm still going to do first simplify and then factor. Okay, so let's see. In the top, can we factor that? We can. That's going to be x minus 3 times x plus 2. And in the bottom, that's a difference of 2 squares. So it'll be x minus 1 times x plus 1. Divided by, that is also a difference of squares, so x minus 2 times x plus 2 divided by, and how do we factor that? Ooh, that's a perfect square trinomial, x plus 1 times x plus 1. Okay, we factored everything, but it's division. Now, if you remember, when we're working with two fractions and they're being divided, we can simplify it by keeping the first fraction, and then we'll change the sign to multiplication, but we have to flip the other fraction. So we can change this sign to multiplication, but that means that this fraction has to be flipped. So let's go ahead and do that. X minus 3 times x plus 2 divided by x minus 1 times x plus 1 divided by x plus 1 times x plus 1. Ooh, a lot of handwriting. My hand's getting sore. Okay, x plus 2. All right. Can anything cancel? Again, you can only cancel when you have multiplication between two fractions, and you can only cancel something from the top and something from the bottom. Let's see. Ooh, this x plus 2 can cancel with that x plus 2. This x plus 1 can cancel with that x plus 1. Anything else? No, that is it. This is a minus 1 and that's a plus 1, so those can't cancel. So we're left with x minus 3 times x plus 1 all over x minus 1 times x plus 2. Ooh, x minus 2. Careful with the signs. They are sneaky. Okay, I think that is pretty much it. Just waiting for my pen to catch up so I can write that down. There we go. And we are done. Again, boxing our answers and making sure our equal signs are lined up. Okay, let's go ahead and move on to adding and subtracting. Perform the indicated operation. Okay, so what is the indicated operation? Well, we have a fraction being added to another fraction. And then for the other fraction, we have a fraction being subtracted from another fraction. So now, when we're adding or subtracting fractions, what is very important? They need to have the same, the same denominator. Okay, super important. The thing on the bottom of the fraction needs to be the exact same in order to add or subtract them. So at the moment, looking at these two fractions, the denominators are definitely not the same. First things I'm going to do, though, I'm going to factor them to make it look a little easier to figure out how to fix this problem. So to factor the denominator, the first one, we'll factor out the 2. And then for the last one, let's see, how does that factor? That is going to be y minus 4 times y plus 2. Okay, so I have a problem. I don't have the same denominator. A way to fix that is to use the building up property and find a number or something to multiply to each of these to create the same denominator. But to do that, I first need to discover what I want my denominator to look like. That's going to be the lowest common denominator. So let me write this out on the side. The way that's easiest to me is to pick the first denominator and write that down. So 2 times x, or 2 times y plus 2. So this denominator is good so far. The second one, we already have the y plus 2, but we're missing the y minus 4. So let me add that in. And now I have created the lowest common denominator. So, oops, I erased a little too much. That is my lowest common denominator. Now, the next question is, how do I make these denominators look like this one? Well, the first one, what is it missing? It is missing the y minus 4, so I have to multiply it by y minus 4. But I need to use a building up property, so whatever I do to the bottom, I have to do to the top as well. Okay, so now that one looks like the LCD. This next one, what is it missing? It's missing the 2. So go ahead and multiply the bottom by 2 and the top by 2. And now the denominators are all the same. So since they're the same, we can go ahead and add them. So we have y minus 4 times y minus 4 plus 2. And they're all over now the same new denominator we have of 2 times y plus 2, y minus 4. Okay, I kind of skipped a small step. I went ahead and added the fractions already. Again, if you want to see the inner step, just go ahead, email me. We can set up an office hour to talk about this. Okay. So let's see, my denominator, I'm going to leave my denominator in factored form. But in the top, I need to multiply these guys out first, and then add the 2, and then I'll know if I can factor it. So multiplying that out, I get y squared minus 4y minus 4y minus, or plus 16 plus 2. Okay, simplifying that, what do I get? I have y squared minus 8y plus 20. All right, 2 times y plus 2, y minus 4. Can I simplify this? Let's see, am I able to factor the top? I think so. I think I can factor that into y. Oh no, I can't factor that. This plus means I need to find factors of 20 that when I add them together, I get a negative 8. And that's not going to work. Again, if you need help with factoring trinomials, please let me know. I'll send you that worksheet that I have. Okay, so we can't factor this, so I'm going to go ahead, leave it in its simplified form, which is y squared minus 8y plus 20, divided by the 2. Now let me catch up to that. Y squared minus 8y plus 20, divided by the 2 times the y plus 2, y minus 4. And that is all that I can do. Again, if I could have factored the numerator, then maybe I could have canceled something between the top and the bottom, but that didn't work out. Okay, so let's take a look at the next one. Again, we're trying to subtract fractions, and in order to do that, we need what? That's right, we need a common denominator, and currently, these two look nothing alike. So again, what's my plan? Factor, and then build up to create a common denominator. So the bottom one, factoring that, that's going to be x minus, let's see, 2 times x minus 1 minus 2 over, and that's a difference of squares, x minus 1 times x plus 1. Okay, now here we go again. Create the LCD. As usual, I just pick the first one, plop that in here, because I know I need to have those in it. And then what is this missing? We need an x plus 1. Okay, so this is what the common denominator should look like. So now for this first fraction, which one of these is it missing? It's missing the x plus 1. So I'm going to go ahead and multiply that to it to create the same denominator. But again, I have to balance that and multiply it to the top. Now the next fraction, what is it missing from this LCD? It's missing the x minus 2. So I need to add that to it. But again, balance that out. I need to multiply that to the top as well. Oops, small error. That should be a minus sign on the inside. Boop. Okay, good. We're done. So let's go ahead and erase this out. I'm going to write that in-between step that I mentioned in the other problem that I skipped over. This is going to be x times x plus 1 divided by x plus 1 times x minus 2 times x minus 1. Make sure our fraction signs are long enough. 2 times x minus 2 divided by x plus 1 times x minus 2 times x minus 1. Okay, let's check. Are my denominators exactly the same? Yep, this is the exact same as this, so I can go ahead and subtract between these two. Before I do that, though, I'm going to go ahead and multiply that out. That's x squared plus x, and then we're doing minus and distributing that as well. So it's going to be negative 2x plus 4. Okay, all divided by x plus 1 times x minus 2 times x minus 1. Okay, let's simplify that numerator. We have these two like terms. It's going to be x squared minus x plus 4 divided by x plus 1 times x minus 2 times x minus 1. Okay, again, this is the step where I'm going to ask myself, can I factor this and then maybe simplify between the top and the bottom? But looking at this, it's asking if factors of 4, I can add them together to create a 1 or to create a negative 1, and that's not going to happen. So that is my final answer. I'll rewrite it without the green, but again, we couldn't factor it, so we're just going to leave it factored. And I leave the denominator factored because that way I know you are trying to find something to cancel. And then we're done. Again, notice how my equal signs, I'm trying my best to line them up so that you can follow my work neatly, and then box in the answer. All right, now let's move on to something called complex fractions. What are these? Well, as the name suggests, they are complex, which means bigger, or in a sense, more complex, right? And they're fractions. So looking at this first one, we have a fraction inside of a fraction. So these are complex fractions, when you have fractions in fractions. And how do we deal with them? Well, there are a few different ways, but when I have a fraction in a fraction and there is a minus sign going on, or a plus sign, or something like that, the method I'm going to use is part of the building up property. I'm first going to find the LCD for all of the fractions and then use the building up property to cancel them out somehow. That is my plan. So looking at these denominators, x plus 1 and x, what is my common denominator? Well, I have an x, and careful, we can't just put a plus 1, because that's a term by itself, so this x would be left out. So if I do x plus 1, I also need to remember to include the x term. Okay, so let me write this out in my own handwriting. So it's a wee bit bigger. And in order to remember that this is the term, I'm going to go ahead and put the parentheses around that. Okay, so again, building up property, I'm going to go ahead and multiply the top of my fraction by x times x plus 1, and I'm going to multiply the denominator, or the bottom of my fraction, by x times x plus 1. Again, I'm doing it to the top and the bottom of my big fraction. And again, my goal, what is the goal? To cancel the mini fractions. Okay, so when I do this, I'm going to go ahead and distribute these in and see if it cancels out my fractions. Let me write this out one more time. With the distributed in fractions, x plus 1, and I'm multiplying to it. X times x plus 1, and I'll put that over a fraction bar just so we can see that. Minus the 1 over x, and again we distributed this in, times the x times x plus 1, and I'll just add that divided by 1 so you can see it's also a fraction. Then my main fraction bar, and on the bottom we have our 1 over x times the x times the x plus 1, and over 1. Again, my goal with this is to see if I can cancel the mini fractions. So this first group, the x plus 1 cancels with the x plus 1. Second group, the x cancels with the x. And the third group, the x cancels with the x. What are we left with? First group, we're left with just an x. Second group, we're left with just the x plus 1. But careful, we still have that minus sign. So I'll do x plus 1, and remember my parentheses around the whole term. And in the denominator, we're left with x plus 1. Wow, would you look at that? The mini fractions are gone. We have done our goal. So again, these are the steps to get to that goal. But we're not fully done. Remember, we still need to just simplify. So simplifying in the numerator, we have x. And we'll distribute that x minus 1 for x plus 1. Simplifying the top, the x's cancel, so we're left with negative 1 over x plus 1. And we are done. Not too bad if you just remember the plan. Again, the plan when you see a complex fraction, first discover the lowest common denominator. Then you're going to use the building up property to cancel out the mini fractions. Once you've done that, simplify. All right, let's move on. Let's see if that plan, again, works for B. So, again, pause the video, try it out by yourself, and then check back in with me in a sec. All right, so hopefully you tried it by yourself, but looking at this, we know it's a complex fraction because we have fractions in the numerator and fractions in the denominator. So again, my plan, first discover the lowest common denominator, and then use the building up property. What is the LCD? Well, I had to be careful. Again, when finding the LCD, I want to make sure that these are all factored, and that one right there is not factored. So let's go ahead and factor that. That's going to be x plus 2 times x minus 2. It was a difference of squares. If you didn't do that and you worked the problem, it's okay. You should have got the same answer, but it might just have been a bit harder. So now we know what the denominators are. So let's go ahead and find our LCD. It's going to be, well, let's see, we know we need an x plus 2. And then what does the other fraction also need? This one also needs the minus 2. So that's my LCD. And what am I going to do with it? I'm going to use the building up property, BUP. And remember, the goal for that is to cancel the little fractions. So with the building up property, I'll multiply the bottom by x plus 2 times x minus 2, and then also multiply the whole top by x plus 2 times x minus 2. And remember, when I do that, this has to distribute to both of the terms. There are 2 terms in the top. Got to be careful. So let's write that out. This is going to be 1 times x plus 2 times x minus 2. We'll bring down that minus sign again, 1, and then we just have the all over, I forgot that, all over x plus 2 times x minus 2 times the x plus 2 times the x minus 2, all over, and this is the main fraction line. I'm just making it bold so you can see. And lastly, putting this one down, we have the 1 over x plus 2 times these ones right here, x plus 2 times x minus 2. And again, why are we doing all this work? To see if we can cancel the many fractions. In this first term, nothing cancels, but in this one, things do. X minus 2, boop, boop. That's x plus 2. And the x minus 2 cancel. And in the bottom one, just the x plus 2 cancels. So what are we left with? This one, nothing canceled, so we have to write all that down. X plus 2 times x minus 2 minus 1, everything else canceled, divided by x minus 2. Okay, again, the denominators are already factored, so I'm just going to leave that alone. In the numerator, we're going to have to go ahead and factor this to add that minus 1. Not factor, sorry, we're going to multiply it out. Doing FOIL. So first, outside, inside, and last. X squared. Ooh, this is the difference of squared. So that's going to be x squared minus 4 minus 1. And that's going to equal x minus 5. Oh, sorry, x squared minus 5 all over x minus 2. And I can't factor that top one, so we're done. Alrighty, and that is it. Again, if you have any questions about any of these problems, please let me know. Best thing to do is to send me a screenshot of the work or tell me the timestamp in which you have the question. If it's easy to answer by email, I will go ahead and do that. If not, we can probably schedule an office hour to go over the problem together. Alrighty, that's it. Please email me if you have any questions.